Hello everyone, welcome to week 3, lesson 1. That's the only lesson this week because we are just going to have a one recorded class this week. Tomorrow we are going to have a live class where we'll be going through all the different assignments you have submitted so far. We'll go through a demo of how a data story is done at Indian Pixels end to end, and I hope that'll be fun for all of you. So hope to see you there. In this week, our focus is going to be on how do we deal with data. So dealing with data is the topic. In the first week, we covered everything about the shape of stories, how do stories sort of are structured. We learned about characters, we learned about plots, and all of the stuff that goes into something that people want to listen to. In the second week, we covered design and the principles of, what makes good aesthetic design. And now, this week is going to be a bridge between all the basic, broad stuff that you learned and to the next week from where we'll start to code and we'll start to, jump into the main stuff. So I love to start anything new with a meme because a meme boils down all the core elements of that part, the core insights in a very simple, easy to access manner. So what do we see over here? We see that they have made an analogy of the whole data pipeline with a set of Lego bricks. Right? The Lego bricks which we used as children to sort of construct all these shapes, they come in different shapes, they come in different sizes, they come in different colors. And so you can imagine data essentially to be just unorganized mess of Lego piles. What do you do with that Lego pile? You essentially take it and you have a mental map of, okay, let's categorize it by colors. So the black goes here, the yellows go here, the greens go here, and so on. So you sort of sort that data, right? And then you arrange it, you arrange the shapes in certain way so that like the square ones go over here, the rectangular ones go over here, and so on. And then you present everything that you have gotten through this sorting and arranging, and that becomes your data visualization. But when you take those insights and you weave this artist magic into it and you create something that people have fun with, like you make a home with it or you make a bridge with it, that is when that visualization transforms into a story that everyone wants to engage with, that it becomes your signature way of expressing how you view the world. And so you can think of data as the building block of narratives. You can think of data as the building block of story. Just like a house is built up of concrete, cement, sand. Similarly, our perspectives, our belief systems are founded on information. And information is nothing but organized and arranged data. Right? So there's another very cool infographic that gets floated around in the DataViz community, which is this. Data is a bunch of random dots, a bunch of unrelated dots that you collect in the world. They are like pebbles in a beach. You shouldn't be married to any pebble. You can pick one, you can throw it, and you can pick another pebble. So that's data, just factoids just pushed on you as you live through life. When you identify, when you classify, when you arrange this data in a certain form, then it becomes information. And then when you start identifying patterns in this information, that is when it becomes knowledge, right? And in this knowledge, when you find all these patterns, but you identify that I want to go from this place, but I need to find a path there, that is when it becomes an insight. That of all this knowledge, you can identify that exact pattern that is going to help you. And finally, when you have identified that exact path, when you have made it simple for everyone, that is when that insight becomes wisdom. This is the process. When that art is domesticated, you tame the wild, wild art and you make it the domesticated design. And finally, if you don't do this in a logical way and you just like string random data together and try to, force an insight, that's when it becomes a conspiracy theory. So, anything that can be perceived or measured is a form of data. I say it because I want you to do away with this notion that data is an Excel sheet. that data is a CSV file. That data is some boring document that you have to open in some code editor and then you have to keep staring at it. Then you have to run some algorithms. Do away with that notion. I want you to see data as any form which can be recorded. The world is a strange, crazy place. Some even say that we don't really see the world the way it is. We filter it through our senses. And whatever we filter when we record it, that is when it becomes data. So when you click a picture, that's data. When I record this video, it's data. Anything that can be measured is data. To cement this point, I want to show you this video which I absolutely love. This is one of those videos which I watched, and I think it got me interested in this strange world of data storytelling. This is the visualization of tau. Tau is nothing but 2 times pi, right? And so what is it? 3.14 times 2, which is 6.28, and so on. So they have taken the digits of tau, which goes on forever, and they have converted each of those digits into a musical note. And there's music generated out of an irrational number. So let's listen to it and let's observe this form of data.
So, you know the rules. Apply all the notes in a major scale, the numbers 1 through 9. Then, apply the major, minor, and diminished chords that correspond with those notes. So, the following is a musical interpretation of tau to 126 decimal places at a tempo of 125.6 beats per minute, which is 6.28 multiplied by 20.
So I'll pause the video here. I think you should watch the complete video on YouTube. It's mesmerizing. It's beautiful. That goes on to show that data does not always look like this. It does not always look like a spreadsheet with rows and columns. It can look in the most mysterious and in strange ways. Yet, the spoiler is you can convert it into a tabular form, and you can then analyze it in the regular pipeline. So maybe you won't find data in the wild world in this regular structured format, but you can break it down into tables which can then be translated into machine language so that you can communicate that data to the programming world. Let's go deeper. Let's see what exactly do we mean by this. So the last table that you saw was from the Dairy Corporation Board of India, and there it shows how much milk is produced in different states of India in different years, right? So this is both a temporal data, meaning it varies across time, and then it's also like a spatial data because you see the different regions. So we see these different values across the space-time. And what we get out of it, we get a map visualization, which we are very used to see on India and Pixels. A map is nothing but a fancy glorified table, right? It's essentially one single snapshot. This here is from the year 2018-19. So the data you're seeing here is basically one column of that table that we just saw. The same data could also be interpreted in the classic bar chart and a pie chart. Usually, pie chart is regarded as the Comic Sans of the data visualization world. No one prefers it. The only time you should use a pie chart is when the values are percentages, so that all of them add to a whole figure. That is when you should use a pie chart. You should generally not use a pie chart if the number of slices are more than 5, because then it becomes very confusing. And the only reason a pie chart is better than a bar chart is because on some level it appeals to that human metaphor within us, that we are cutting a cake and everyone is having it. But almost always a bar chart is better than a pie chart. Visually you can look directly through the order in the bar chart, which one is greater, which one is smaller, and sometimes in a radial way it's not very visible in a pie chart. So that same tabular format can be expressed in many forms: maps, bar charts, pie charts, something that we are all mostly used to. But I want to show you some visualizations that don't exactly, fit our conventional ideas about how data looks like. For example, look at these strange visualizations. So the first one is all the different interactions characters in Game of Thrones had with sub characters. So the more dialogues someone had in Game of Thrones, the larger the circle, and the more they talked with someone, the larger the width of the line that joins them. So you see here the largest one seems like Tyrion, who had a lot of conversations with Sansa, with Jamie, with Robert. They are all the blue clusters. You can group this whole sort of branch into different clusters. On the north, you see Jon talking with Mance and Sam with all his, I forget the name. What were they called? The crows? The wall protectors? But yeah, the Night's Watch. Yeah, how could I forget? And then Dany there, Daenerys talking with like her, Essos people. And so in one snapshot, you can visualize who was close to whom, who did someone talk to, right? And this is called a graph or a network diagram. And a network diagram essentially consists of different nodes, right? Different dots which are connected to each other through edges. And there's a legit whole theory in mathematics called graph theory, where you can study different parameters of this structure. What is the clustering coefficient of something? What is the distance between two nodes? All of that fancy stuff which we won't delve into, but visualizations can be in this form. And it's not super obvious how would you express this in a table, or how, like, if you had to jot it down and express it to a computer, how would you translate it? So that's a little unintuitive, right? On the right you see the Delhi metro network, right? And you see like all sorts of crisscrosses happening, and it's a geographical overlay on top of a map. So the points have certain geographical connection, but in this metro diagrams we simplify it, so it's called a schematic network diagram. And here you see the different circuits, right? The different circles of the Delhi metro. Right now I guess they have like more and more things coming up. This is from like a couple of years ago. So visualizations like this are formed by a lot of richer data, something that is not easy to express in just like a row versus column format. You can see a similar structure in this visualization: the global weapon trade from 2009 to 2015. Here we see similar clusters happening. So the two major ones being United States and Russia, and you see India is super close to Russia, right? And until 2015, I think like India generally didn't get a lot of arms from US. Maybe right now it's somewhere in the middle, but yeah, you can see like the giant alignment of the world in the US Russia circle here. So again, this is a little confusing about like how would you express this, right? A classic food chain, different animals, something is eating something, something gets eaten by something else. And so in this case, these edges that were connected have a sort of directionality to them, right? So a goat is connected to a jackal in the sense that a jackal eats a goat, but the goat does not eat a jackal. So you can also encode in the visualization which direction is this connection pointing to, which is indicated by the arrows that are shown here. I want to show you a project that I had done like way back. I think it must be like 6 years now. This was shortly after I returned from Media Lab, and I was, sort of wondering how does my Facebook network looks like. It was also around the time when Facebook got into the Cambridge Analytica scandal, and it was found that they were using these network theories to sort of manipulate elections through advertising and influencing people. So I got curious to know how does my Facebook network looks like, and this is the final output. Spoiler alert. This giant cluster essentially is a huge blob. All the dots that you see here are basically people in my life. And similar to the network diagram where the dialogues were the weights, here the number of times I have messaged someone is the size of the dot. So the darker a dot, the larger the dot, the more I have talked with them. So I had created this sort of animation where all of this starts with a bang from a big little circle, and then it explodes. And the people who are friends with each other, they sort of come together, and the people who are not, they explode out, right? So let's see how it works. So the simulation starts with an explosive start, essentially. Each of those dots again is a friend of mine. That largest dot was my best friend at that time. And so you see all these different clusters start separating from the very edges. So if you zoom in, each of these is a name, right? So you see them floating all over in this friendship universe. So one part that is going is my family, who are friends with each other. So they are sort of being repelled by everyone else and they are isolating themselves. Over here, this cluster is my high school, and in similar fashion, different clusters sort of separate. So now we will fast forward this animation, and finally, yep, that's how it looks like. And the way I did it is I scraped essentially Facebook. This was a time when you could do that. Facebook wouldn't ban you just immediately, which would happen, I guess, if you do it right now. So I wrote like a Python script where I used a tool called Selenium. So Selenium can control the browser for you. So it will be like a human is controlling your Google Chrome, but it will actually be code that you have written. So it went to each friend's profile and it would scrape all the friends that they have. And then it would see if two friends of mine are friends with each other or not. It looks something like this. For each person, I created a file and that contained all the different friends that they had. And finally, I boiled it down into two separate files. One was called notes and the other was called edges. So what do we see in the notes file? We see literally name of different people. And before the name, we have the IDs mentioned. And to the right, I have how many messages I have had with them, right? And in the edges network, we have 4 different columns essentially. You can ignore the last one because it has weight and that's just one for everything, right? Because we are just measuring. I cannot say how much they talked with each other, otherwise that would have been a nice proxy for that weight. But we just know that someone is a friend, then 1, If they are not, then it's a 0, right? So in the edges network, we are just mentioning people who are friends with each other. So source and target, they are exchangeable. So the source is the friend number 1, so that is Shivam, and the target is the other friend, right? So friend number 689, 953, 341, all of these are friends with Shivam, and so we have mentioned them, and the type is undirected. And then using a software called Gephi or Gephi, Gephi, I just fed both of this data, and that is how I got this visualization. There's also another visualization called the Sankey flow. So here we describe how does one flow transform into another kind of flow, right? Here we see Stats of India visualize the Indian Union budget of 2023. On the left, we see where the money is coming from, and in the right, we see where the money is going towards. And even here, it is not super obvious how would you express this in a form of nice simple table. But similar to what we had previously, we can express this in the form of two different tables. The first one being input and the other one being output. And then there are many online tools where you can convert this into like a nice little Sankey diagram, which is something Stats of India also used. So the point being, a lot of data sets, although the final visualization might look very different, you usually have to convert that into some sort of a table. Now, people have their own ways of doing things. My favorite tool is literally Google Spreadsheet. It depends on what domain you are in. Sometimes it is just not possible to even load all of the data set in one Excel sheet because the data set is so huge. But generally speaking, if you're in the field of data storytelling, you are generally dealing with data that you can open in an Excel sheet or you can open in a Google spreadsheet. And I like Google spreadsheet a lot more because once you upload it, you can share that file as a URL. You can even publish it out in the open and then even use Google spreadsheet as a sort of database in a lot of web applications. So what's the benefit of doing all this transformation into a spreadsheet? Well, the simple answer is that it is very easy to convert a spreadsheet into something called a JSON. JSON is a JavaScript object notation. It's a form of expressing data. Something that you see in the screen right now, that's a valid JSON form. A JSON is basically a combination of some key value pairs. So what is a key value pair? Imagine I'm a student and my data can be represented as name, Ashrish, age, 28, house or like home, Odisha, and pin code 721302. So this key value pair is a JSON essentially. So let's say I have a table that looks like this. Subjects are the column titles and the rows are essentially student names. And then the values are all these different marks that students have scored. I can download this spreadsheet essentially as something called a CSV. So if you look at how this downloaded file looks like, it's essentially all these different values in that spreadsheet separated with a comma. So it's comma, the first one was empty, comma, maths, English, science, then the next line, Abhishek, comma, 12, comma, 15, comma, 19, pretty self-explanatory. Now, using a tool, something like csv2json.com, which, was a tool we used at Indian Pixels all the time before we had iipmaps.com. Here, if you go to this website, there is a tool called csv2json. So if you upload this CSV, then you see it gets loaded over here, and then you can convert it into a JSON, right? And notice how here you have all these different transformation options. So you can output this as an array, So an array is essentially just a list, right? So the square brackets start, and then each of the items is a dictionary where we are showing like the name being Abhishek. Like if we can have the starting as name, and then if we convert it, notice how it says name Abhishek, maths 12, English 15, science 19, and so on, right? You can convert it into a hash or a dictionary instead of an array. So notice that initially it had like square brackets. Now look what happens. If I convert, the square brackets disappear and now it starts with a curly bracket. And then the keys, instead of saying name Abhishek, now the key becomes Abhishek. There is also an option called transpose. If you do transpose, what happens is the main keys become the subjects, and then your students become the inner objects. So depending on how you want to code, you can convert your spreadsheet in all these different ways. It's a very simple, nice tool. Initially, you had to do all of this through coding, right? You had to download it, then you had to write a Python script. But I use this website all the time. It's very versatile, and it's one of the many things that you can use. If you find out something else that works for you, well and good. But this is something I would recommend if you're just starting. So spreadsheets and Excel sheets are great ways for humans to look at data, to look at sort of visualize the data. But the world of computers, they understand data through JSON, or this structured way of representing data through dictionaries and objects, which we just saw. And we saw that it is easy to convert a CSV into a JSON, right? A spreadsheet into a JSON. There are APIs, or basically just links, that if you click, you can get data as JSON. So for example, here we have this API from Post Office, Indian Post Office, api.postalpincode.in/pincode/. If you add anything over here, if you change this value, you will get different responses. And then you can use this in your code or in your, whatever application that you're building, where you can just change this URL, and then this data will be keeping on becoming different. So APIs are ways for us to request for a huge data through these sort of links. Often data does not come in neat spreadsheets or even nice APIs which will give you a JSON data that you can use. Sometimes these are PDFs, right? And PDFs are notorious because they are so unstructured. There is no guaranteed way of a PDF rendering values correctly. For example, this is a PDF from the Reserve Bank of India. If I click on this, you see that this is a report on globalizing people. So here, look how the data flows in a certain way, right? If I select this, it only selects things from this one column. After it selects, then it goes into the second column. So this structure is unique to this PDF. In some other PDF, it could be like if I start selecting, it will include the right thing as well, but not in this case. Then you see in that same file with text, you also have this table, right? What happens if I try to, select this table and say I want to copy this and I want to have it in a spreadsheet, right? So let me just do Control V. Look what just happened. So that was a table there, but when I paste it, it all appears in one line. And this is a very common thing in PDFs, that there is no guarantee that you can copy a lot with a structure and it pastes very neatly. And that is just one good case, in fact, where you can at least select the text. In many cases, PDFs are, just flat images and you can't even select stuff. So what do you do in such cases? Well, one nifty website that I generally use is called Extract Table, right? This is a paid tool, although they generously allow two free images to be uploaded. So I usually open like incognito tabs and I try to get over this limit, but you should not. Okay, I'm not advising that you should. But in this website, if you upload a screenshot or an image, then this very nicely extracts that information out, and then you can copy that and you can sort of paste it. Let's try to recreate this. Let me give you a demo. So let me go here, Control Alt Shift 4. So I took a screenshot. So let's try to upload this in extractable.com. So the file is over here. It says you are on the demo page that allows only 2 image conversions per day. Do you want to upload this file? Yes, we do. So as soon as you upload it, it does its scanning thing and voila. You have all of that data neatly mentioned here. If the website is unsure about some values, then it will mark it in red so that you can, verify that they are right. You can click on this thing called copy to clipboard, and then over here you can neatly paste it, and there you have it. That PDF just became a nice little spreadsheet which you can analyze or you can do whatever with it. So the modern day AI chatbots have also become very good at doing stuff like this. So you can just upload this PDF in any AI chatbot and ask it to extract this data for you. And you should ask it to generate this in a CSV format, because otherwise you will run into the same issue of, having issues of like pasting it in spreadsheet, and then it'll be an issue. So we will specify it to generate like a CSV that we can directly open in Google Spreadsheet. So I'll upload this file over here and I'll say, can you extract table 1 as a CSV remittance share by state. So over here it opens this artifact, right? So we may now download this artifact. We get the CSV file downloaded. I might have to rename this from txt to CSV. And now I may upload this over here. So after you do this, ta-da, you have the same data. If I just copy this, if I paste this over here, you see we get the same data as extract table, and yeah, there you have it. So you might use like an online tool, or you can use a AI chatbot to extract stuff from a PDF, right? And this is something you will be needing a lot as we go forward, because there will be all these data sets in the wild, and most commonly they will use PDFs to present their data, and more often than not it will be extremely difficult to simply Control C, Control V it. So you'll have to use these different strategies. So where do we get all this data from, right? A lot of people ask us, all these visualizations that you create in Indian Pixels, where is this data coming from? Well, it's just good Googling skills. Like you can Google stuff, and you can use hacks like putting things in quotes to only get results that have that specific code. But I just want to point out some of the well-known locations. So the first one is the National Family Health Survey India. It has a lot of data on health. They do this pretty frequently, almost they do it every 5 years. So the NFHS 5 was in 2019-21, and then to NFHS 4 was in 2015-16. So similarly, the next NFHS will be the next year, the coming year, right? NFHS 6. So every 5 years they do it, and they present all of these very interesting data sets that you would be seeing over here. So all of these are created using NFHS data. Then you might also refer to the Reserve Bank of India Handbook of Statistics. So this has a lot of data on the Indian economy, GDP of different states, GDP growth rate, per capita, and per capita se yaad aaya, like a lot of the times you would have to make this decision of like what kind of data do I have to pick, right? Do I report this in absolute terms, or do I report this as a per capita form? That depends from place to place, but generally anywhere where it is pretty obvious that more the population, more the value, that is where you should per capitalize that data. Otherwise, you're just expressing how population is in different states. For example, if you are visualizing something like number of post offices in different states of India, it is no wonder that Uttar Pradesh might have the highest, simply because it is the most populated one. So you might divide this number by the population, and that way you get the per capita value, and then that will give a better understanding. It will be less harsh on smaller states, but in some ways per capita also largely exaggerates the value for smaller states. So per capita income, for example, is extremely high for Sikkim and Goa, and yet the most important states in India are not Sikkim or Goa. They are like Maharashtra or Tamil Nadu, who have the absolute GDP. So use your judgment to decide how much weightage do you have to give to the per capita value or to the absolute value. There's no hard and fast rule, right? So take that wise decision. You might also get data from the Economic Survey of India that is published almost every year. So they condense a lot of the information that comes from NFHS or whatever is presented in the union budget, and they document it in the union survey. But all of these are very domain specific, right? How do we get different domains ka data? So you might just go to this website called MOSPI, which is Ministry of Statistics and Program Implementation. So there's a legit department in the Indian government whose job it is to collect statistics, to collect data. So you can find a lot of interesting reports in this website itself. You can also go to the Lok Sabha questions and answers that get asked. A lot of interesting questions are asked by members of the parliament to the ministers, which they reply, and their replies are documented really nicely in this website. So this is a good place to go. You can, let's say you're searching for number of zoos in different states of India. So you can say number of zoos and then add Lok Sabha questions in Google, and then you will find something. Actually, let's do it directly. Number of zoos, Lok Sabha question. And ta-da! You get the first link itself. It's from Digital Sansad. And here you see this is unstarred question number 5213. Dr. Amol Ram Singh says, will the Minister of Environment, Forest and Climate Change be pleased to share the number of zoos in different countries, state-wise, A, B, C, D, E, F, and then the minister with his team, they have to, come up and present this data. So there you have this table over here. And then you can use a similar, let's try copy pasting this and see if that works. So Command C. Let's go over here. Let's paste it. Similar issue. So again, we'll have to either take a screenshot or do something about it. Actually, in iipmaps.com we have like this baked into that tool because we run into this pasting issue so often. if you just want to make a quick map, you might go here, you can click on paste values, and over here you can command A V, you can paste this whole thing over here, and then if you process this, I'll remove this one. Yep, you see we get like this clean thing, so it does this cleaning stuff automatically. So you may also use IIP Maps tool to sort of generate this clean data automatically. So many ways to clean data, to source data. I hope all of this will be useful to you when you're searching for data, right? And yep, there's also this infamous website called data.gov.in. I say infamous because they have a lot of data sets, but usually they're outdated or sometimes things are missing. So it's usually like a 50-50 thing. But this was one of the pioneer websites to start documenting. And very recently we have gotten a game changer website called NDAP, where they have collected different data sets from different sectors. This is like an initiative by the Niti Aayog, definitely 100%, 100 times better than data.gov.in. So here you can get data from like all these different sectors, from agriculture to education training to energy and power, petroleum, whatnot, right? And you can click on each of these and you can see share of top 10 states. This is from very recent as well. Data.gov.in sometimes has data from like 2011 or 12, but this has little like recent data, and they keep on they keep on improvising, they keep on adding and updating this stuff. So you will have to create an account. I have already created it one over here. It's pretty simple to just sign up, and once you log in, you can either just like export the data set, you can download this, and you will get a zip file, or you might visualize the data here in the website itself. How cool is that? So you may come over here and you can select which kind of chart do you want to create. So let's say we want to create a line chart, so it asks us what do we want to pick in the x-axis and the y-axis. So let's say in the x-axis I want to visualize the year and the month. Okay, I have to select just one, let's say the month. And in the y-axis I want to select foreign tourists arrival, right? Let's just apply this, and you see a line graph is generated right here. So this website has, you can collect data, you can visualize on the go, and yeah, it's pretty cool. So use NDAP. Not a lot of people surprisingly know about it, but yeah. Then there is this data set of data sets made by my very good friend and my mentor, Gurman Bhatia, who inspired me to get into data visualization in the first place. And in fact, she was so kind to join our course as a student. So hooray, Gurman, if you're watching. And in this very nice table, she has compiled a list of data sets that you can look at. So this has all this interesting stuff like details about animals, details about mangoes, the crop situation of India, oxygen shortage during the whole COVID thing, liquor prices in Delhi, and this is a huge list. You may find a lot of interesting data sets over here as well. Then you can get some inspiration on Reddit, like I did initially. So it's a good idea to follow these different channels like Data is Beautiful, or there's MAPPORN Reddit channel. So there they create like map-based visualizations. Then there is this website called Information is Beautiful, and they have annual awards for the best visualizations created. And in fact, they are having these awards again this year, and the deadline will be somewhere in 2025, actually before our course ends. So I hope some of you submit the visualizations that you create in this course to this awards website. And other than the whole competition, this website has some beautiful repositories of data visualizations. In fact, in our live class tomorrow, we'll go through some of the very beautiful, interactive stories that have inspired me, and we will play around, and I'll love to hear your thoughts there. Right, and then there is this good old Kaggle where you can see a lot of data sets present over there. And yep, that's it pretty much. So this was a quick primer on how I basically collect data, where do I get this data from, and what elementary cleaning ways do I use to sort of work with data. I didn't want to overwhelm you. This was intended to just be like a short thing. We'll learn obviously as we do things, and yeah, that's pretty much it. I hope to see you in the live class tomorrow. I will see you in the coming week then. So, all right. Take care, everyone, and let's be prepared for the next week. See you.